Hi, it's Jocelyn, and I'm about to do Advent of Code Day 12. Alright, so we have these look like locales or something. Passage pathing. Oh no, it's a map. Okay, number of distinct paths that start at start, end at end, and don't visit small caves more than once. Okay, so I know for a fact that we're going to need this example, so I'm just going to start with that. Oh, sorry, the cave system is this. And there are 10 paths. All right, let's do this. So for each line, we are going to split. Somebody pointed out there's split once, so let's try that on this dot unwrap. And so we have from and to equals that. We like hash maps, so anyway, we can go in both directions. So we're going to insert from and then to, but we're also going to insert to and then from. Because you can go from start to VR, but you can also go from VR to start. And then what we're going to do is try to enumerate all the possible systems. So I'm going to make a separate function for that, which will take the system, which doesn't change, and also takes what the small cities we visited so far, or small caves that we visited so far. So, because then we can't visit those again. And it counts it counts number of times for which we can, number of different distinct paths. We also need a function is small, which takes a string and returns a Boolean. And this is just going to take the first character and return true if it's lowercase. Okay, so oh yeah, we also need to know where we're at. So we'll call it at. And so if we are at the end, then that is one path and we're done. And if we're not, then we see where else we can go. So I realized something. This from and to. So hash maps only support one thing at a time, but we actually need to support multiples, so we need to fix that. So what I'm going to do is just entry from or default dot push to, and then vice versa. So this way, we probably do need to specify the type, but this way we can have multiple caves from a single system. And then we're going to just enumerate them. So enumerate system, we start at start, and visited starts at nothing. Okay, and it's a U size. So if we're not at the end, going back to this, for, oh yeah, and this is now just a vector of strings. So for 2 in system dot get the city we're at. I'm just going to call this from. That's easier. Okay, so if it is small and we visited it, then we just continue. We can't go back that way. Otherwise, actually, so if it's small, if we visited it, we just continue. We can't go back that way, like I said. But otherwise, we need to add it to visited. Okay. And at this point, now we're going to go over there. So count plus equals enumerate. System, we're now at 2. And we're going to take our visited thing and just clone it. We also could make it mutable and insert things as we go and then pop and then remove them as we pop them from the stack. I think this is just a little bit easier. This needs to be a reference. And again, we need to do that. Okay. Right, because this is an option. That is kind of annoying. I'm going to see if this works. If they're sneaky, there might be some cities that are, or some places that are just dead ends. Let's see. Okay, I don't know what that's complaining about. Oh, so first of all, this needs to be this. This is also going to need to be mutable. We'll just take a shortcut there. Okay, these all should be the same lifetime. I'm just going to specify that explicitly. The idea is that none of these things go out of stack or out of memory while we're doing that. Okay, and we got 20, not 10. So let's actually just showing you there. The output says 20. We're expecting 10 here. So I'm not exactly sure what I did wrong or where to start. So what I'm going to, because you can go in both directions, right? Okay, so what we want to do now is just print the paths so far, just so we can see if they match what we expect. So I'm just going to make a new variable paths here, which is just a vec of strings. Okay. Or just, I guess that'd be path. Path equals path.clone, and then we're going to pass it into here after pushing wherever we actually, yeah, here we're going to say path.push from, and that's perfect. And here we're just going to clone it. Again, we could push and pop it from the stack, but it's just easier to get right. All right, and here we're just going to print the paths we get. It should be a debug string and path. Right, that is, that goes there, not there. Okay, so now we have our list of paths, and let's try to find out how this mismatches with our with the example given. So start is, okay, so this is going back to start sometimes. So it looks like we're just missing that first one. So we could also perhaps move where we did visited. That should also work. But I have a good feeling about this because that looked pretty promising. Again, that's 9 though. Okay, which one am I missing? Okay, so start A, B, A. Let's see. I'm bad at processing these. Because the order we have is different than the order they have. Okay, so I don't have a fast way of doing this. So I'm just going to check each one manually and see. Yeah, I'm going to check each one manually from the instructions and see if it's there. So start A, B, A, C, A, end. Start A, B. That is the one we're missing because we have the rest. Start A, B, A, end. Start A, B, A, end. Great, okay, so why are we missing start A, B, A, C, A, end? I actually don't know the end. That is really weird. I'm just seeing like how far we're getting here. So we're not getting there. Okay, so we are getting AB. And we should be getting ABA because we do go back there. Okay, but we're getting ABA, C. We're not getting ABAC. Why is that? Oh, it says when we have ABA that we have visited C, which doesn't... Okay, so my mistake here is that we are I was forgetting that visited is like not reset on every instance. So this actually would have been like so we had 2 mistakes because of this. It would have been better to just push visited at the beginning. I was just doing this from scratch. Beginning of the function instead of where we currently have it. That's caused 2 problems. But now we should have an answer. Oh, apparently I'm printing all of those. That's fine. And we got it right. Okay, continuing to part 2. And that was a really stupid mistake. After reviewing the available paths, you realize you might have time to visit a single cave twice. Specifically, big caves can be visited any number of times. Single cave can be visited at most twice. A single small cave can be visited as most twice. Yeah, this seems pretty similar. I'm going to actually reuse part A here. But I'm going to add a thing, which is just going to be part B. And I'm going to add a new test for our second example since we have one here. 103 paths. Okay. So I'm going to add a new field to enumerate as well, which just says, I can't think of a good name for this, but small. Okay, well, we'll just pass part B along, and I'm just going to call it supports one small supports dupe small cave. Okay, so we just need to change this line now. So if supports dupe small cave, we're going to do this. We're just going to shadow it so it doesn't change on the next instance. Then we're going to say supports dupe small cave equals false. We're going to pass this over here. And we also said that 2 cannot be start and 2 cannot be end. Doesn't really matter because we start counting as end, but that should cover, I think that should cover everything. Except for the fact that I will never ever learn when I should actually dereference them. I mean, the rules make sense, it's just a lot to keep track of. That needs to be mutable, standard mistakes I always make. And we probably don't need to print all these. Part B should be true here. We got 36, not 103, so I'm just, okay, so obvious small mistakes here. We are oh, the slightly larger example has 103, so let's make sure we're actually doing the right example. Amazing, we got that right. And we have a new answer, so let's see if that's right as well. Wonderful. Thank you so much for watching, and I will see you tomorrow.